How the Sun Powers the Earth. Dylan Finney, Physics 2020, April 27, 2018. Introducing the sun's importance. Photosynthesis allows plants to receive, absorb, and convert light energy from the sun into chemical energy that can be used as a source of food or fuel to power the internal mechanisms that a plant must carry out to live. Animals can then gain energy and nutrients through eating plants, followed by humans gaining energy and nutrients when they consume plants or animals. Thermal energy from the sun heats the earth to optimal temperatures so that daily processes are able to occur in the outside environment along with the environment inside all organisms. The thermal energy we receive is in the form of infrared radiation. Without light from the sun, food would be scarce and the world would be dark and cold. Physics of energy created by the sun. Nuclear physics is a field in physics that studies atomic nuclei, what they contain, and the interactions they have within them and between themselves or other particles. From this field, we learn about nuclear fusion of hydrogen gas atoms into helium seen inside the sun. This occurs in the core layer of the sun due to the pressure there caused by gravity pulling the components of the sun inwards toward the core section. This forces many particles into a very small space, increasing the pressure seen here. The fusion of hydrogen to helium that we see in the core is the main source of energy produced by the sun. The picture here shows the main reaction that is between 4 hydrogen nuclei, 2 electrons, in creating 1 helium nucleus, also known as a helium-4 atom, containing 2 protons and 2 neutrons. Energy is a leftover product from this reaction. Steps of hydrogen fusion into helium. About 85% of the sun's energy is created by these 3 steps alone. 2 protons combine to form a deuterium atom, which is a hydrogen isotope with 1 neutron and 1 proton. It also creates a positron, which is like an electron but has a positive charge rather than negative, and a neutrino, which is a neutral lepton. A lepton is a half-integer spin particle that does not undergo strong interactions. A proton and deuterium atom combine to form a helium-3 atom, which contains 2 protons and 1 neutron, along with emitting a gamma ray. 2 helium-3 atoms combine to form helium-4, which contains 2 protons and 2 neutrons, along with producing 2 extra protons. The helium-4 product has a lower mass than the 4 protons that act as the reactants in the overall reaction. This difference in mass is the sole cause for the transformation of mass into a form of energy. Steps of hydrogen fusion into helium continued. About 15% of the sun's energy comes from these following reactions. After the previous slide reactions happen, a helium-3 and helium-4 atom will combine to make beryllium-7. This contains 4 protons and 3 neutrons. It also emits another gamma ray. The beryllium-7 atom can capture an electron and becomes lithium-7 atom, which has 3 protons and 4 neutrons, and a neutrino is also created. The lithium-7 will combine with a proton and makes 2 helium-4 atoms. Physics of energy created by the sun continued. Once the nuclear fusion occurs, there is a conversion of mass to energy. The mass comes from leftover mass seen at the end of the nuclear fusion reaction when helium-4 is created. The leftover mass is free rather than tied in the helium-4 atom because of an interaction called binding energy seen in the products. This means that the particles inside helium-4 are being held together more tightly than normal, which is allowing the overall mass to be less than it should be. At the end of the reaction, the reactants on the left side have a larger mass than the products seen on the right side of the equation. Extra mass can be converted into energy based on the relativity theorem from Einstein. The equation correlating with this theory is E equals mc squared. The energy created can be of several different forms, such as kinetic energy, also known as the energy of motion, thermal energy, used as heat, and chemical energy, used as fuel for internal processes. Theory of relativity. The theory of relativity was created by Albert Einstein and says that mass and energy are of the same physical entity. This allows them to interconvert from one form to the other. The positron and neutrino created from fusion, for example, go flying off with the energy they gained. They gained this energy by transforming the extra mass from the earlier reactions into energy, specifically kinetic energy or the energy of motion. They convert mass to energy based off of the equation E equals mc squared. The E equals m part of the equation shows that energy and mass can be converted into each other. The overall reaction shows that nothing can reach the speed of light. It then states that the amount of mass you want to make travel at the speed of light determines the overall energy needed to do that. Layers of the sun. The core is the innermost layer, and it is where we see the most increase in pressure. This increase in pressure allows nuclear fusion to occur, meaning this is the layer where most of the energy of the sun is created. This energy travels up the core into the radiative layer. This layer takes the energy traveling from the core towards the outer sun. It carries the energy in photons that collide with gas molecules and become absorbed. Absorption heats the gas, causing another photon to be emitted. This is a recurring cycle that happens until the energy is moved up the radiative layer and into the convective layer. This layer is made up of plasma just like the rest of the sun, but uses the plasma to create convection currents. These are currents of rising movement of hot gas with simultaneous downward movement of cool gases. This is also a recurring cycle happening until the energy reaches the photosphere. The photosphere is the outer layer of the sun and is the actual visual portion of the sun. It has flares of energy radiating off of it, and these waves of energy are directed towards the earth to give it the light and heat it needs to live. How objects on earth receive sunlight as heat. Some radiation emitted from the sun meets objects on earth as infrared wavelengths and pushes photons into these objects. The photons have electronic energy that can excite the electrons in the atoms of the object. Exciting enough electrons in enough atoms can cause the vibration of the entire molecule. The atom and molecule will no longer be electronically excited, but vibrationally excited. The vibrations occurring create the heat that we feel when an object is being warmed by the sun. In the picture, you can see that direct sunlight can either be absorbed and increase the surface temperature, or can be reflected away as light. Black or dark surfaces absorb all wavelengths of light. This is what makes them appear black and also makes them hotter because they receive the most heat due to not reflecting any light away like other objects do. Instead, they absorb it all, increasing their surface temperature to the max they can. How objects on Earth receive sunlight as white light. Why does the sun appear yellow from the Earth but is actually producing white light? White light is a combination of wavelengths of all colors equally emitted that a glowing object can produce. The sun's surface is so hot that it produces many wavelengths of color, creating an overall white light. Cooler areas, for example, produce a red wavelength, and hotter ones a blue. Different wavelengths, such as red and yellow, are seen only after the light enters the atmosphere. These wavelengths are seen because blue and violet wavelengths have been dispersed by the atmosphere and are seen as a blue sky. The sun hits Earth with different angles throughout the day, causing the different wavelengths to be reflected by the atmosphere and allow different colors to be seen, such as a red-orange sky color at sunset rather than a blue sky, because the red-orange wavelengths are being scattered rather than the blue and violet ones that we saw earlier in the day. Different heat intensities from the sun. A certain region of the Earth is tilted towards the sun during its summer season. Although it is pointed towards the sun is a further distance away from that region than it would be if the region was pointed away and in its winter season. This is because the sun is higher up and in the middle of the sky, allowing direct light to hit that exact region. Direct sunlight allows for more warmth to be felt. The sun is also out longer in a day, considering it is higher in the sky, so this allows for more warmth to be felt and collected. Different heat intensities from the sun continue. That same region of Earth is now pointed away from the sun during its winter season. The sun is lower in the sky and creates an angle of light between the sunlight and Earth. This angle between the sun and Earth causes less direct sunlight to hit that region. There's a greater surface area the sun rays must hit, and in a dispersed fashion as well. The sun can still be bright in the winter, but the increase in surface area the thermal radiation must travel causes a decrease in the amount of heat allowed to reach that region and be felt.